Hi everyone, welcome back to my Scanpy video tutorials. Today I'm going to show you some core plotting functions in Scanpy. In my previous video, we analyzed a single-cell sequencing dataset for human fibrotic lung. We annotated the cell clusters as myofibroblast, fibroblast, smooth muscle cells, parasite, and two small cell clusters, endothelial cells and immune cells. Because these datasets are mesenchymal cells purified by flow cytometry, so let's subset the cells and just keep the mesenchymal cells clusters. If we plot the cell clusters, you can see now we only have myofibroblast, fibroblast, SMC, and parasite cell clusters. Later we want to show t-SNE and dendrogram in our plot. So let's perform t-SNE and dendrogram cell clustering analysis. If we have a look at the A data now, you can see we have the t-SNE and the dendrogram laden information in the unstructured layers. We also have the X-t-SNE information stored in the multi-dimensional observations. Now we can use our data to demonstrate the core plotting functions in Scanpy. So the first plot function that we are going to introduce is the scatter plot. It is a generic plot function to visualize cell clusters. You can specify which cell embedding method you want to use in the basis argument, such as PCA, Umap, and t-SNE. Let's run the scatter plot. You can see we have 4 cell clusters as the Umap plot because we specified the basis as Umap. But it is very rare to see people directly use the scatter plot. We can directly use the PCA, Umap, and the t-SNE plot. So we can try the PCA plot. You can see we have 4 cell clusters, but the two-dimensional embedding for the cell clusters looks different from the Umap clusters. We already used the Umap plot in this tutorial. Umap plot not only is the best plot for trajectory analysis, but also is the most commonly used plot function in single-cell RNA sequencing data analysis. Let's run the Umap plot again, and we have 4 cell clusters here. If you prefer to show the cells using t-SNE, you can run t-SNE plot. In the t-SNE plot, we can see more distinct cell clusters. So let's focus on the Umap. We can use the Umap to see the cell clusters. At the same time, we can visualize gene expression level in each cell cluster. For example, here we plotted the cell clusters using the color argument as laden. At the same time, we plotted the gene RGS5. Let's run the plot. You can see we have cell clusters labeled on the left-hand side image. On the right-hand side image, we can see RGS5 is highly expressed in the parasite cell cluster. We also can plot several genes at the same time. For example, we plot 3 marker genes for the male fibroblast cell canister, CTHRC1, collagen 1A1, and peroxistin. You can see these marker genes identified the male fibroblast cell canister. If you would like to plot more marker genes, you can use the n columns argument to organize the images. Here we plot 6 genes and use n columns equals 3. Let's run the plot. You can see we use n columns equals 3 to show 3 genes in each row. If you have a look at the API for the Umap Plot function, you can see there are lots of parameters that you can adjust to produce an image according to your need. For example, we can add the outline on the cells. We can change the legend font size. We can remove the frame outside the cell canisters, and we can add a title for the image. You can see we removed the outside frame. We added the outline on the cells, and we also named this image as the canistering of cells. Okay, let's move on to show the second important plot function, the dot plot. We can use the dot plot to check the expression level of genes in each cell canister. Before we run the dot plot, let's set a dictionary for marked genes. We can use the cell canister name as K and list 3 marker genes for each cell canister. Now we can run the dot plot for above marker genes. And we add the dendrogram to the graph to bring together similar cell canisters. You can see here, the MSC canister is more close to the parasite canister, and we know male fibroblast were derived from fibroblast. The dot plot tells you 2 types of information. The color represents the level of gene expression in each cell canister. Here we use white to dark brown color. The dot size indicates the percentage of cells in the same cell canister expressing a gene. Wiring plot is another plot function that has been frequently used in publications. We used the wiring plot in my first video when we performed the quality control analysis. We can use the wiring plot again to see the n genes by count, total count, and percentage of mitochondrial DNA. Here the RC context is used to set the figure size. We can use the strip plot force to remove the internal dots, and also use the inner box to add a box plot inside the wiring plots. Now we can see n genes by counts for each cell canister, total count for each cell canister, and mitochondrial DNA percentage for each cell canister. If we use the wiring plotter to plot marker genes, you can see the wiring plot can show the gene expression values across different cell canisters. Once again, you can see the CTHRC1, collagen 1A1 show high expression in the male fibroblast canister. For the widening plot, there is a stacked widening plot function. This function is very useful. It can help us to save space when we prepare figures for publication or for PowerPoint slides. If we run the stacked widening plot for the mark genes, you can see here, stacked widening plot can show our mark genes in the same figure. This will save a lot of space for us when we prepare images. Next, we introduced the heat map plot. You probably noticed that the heat map plot has also been frequently used in publications. We can use the group by information to show the cell clusters. I swapped the axes in this plot. The y-axis shows the gene name, and the x-axis shows the cell clusters. In the heat map, each cell is shown in a column. Here the yellow color indicates high level of gene expression. We can also use a track plot. The track plot shows the same information as the heat map, but instead of using a color scale in the heat map plot, the gene expression level in the track plot is represented by the height. You can see for the DES gene it's from 0 to 4, for the pyroxene gene it's 0 to 5, and the expression very high for the collagen 1A1 in the fibrotic line, especially in the myofibroblast. You can see it's from 0 to 6. So the last plot function I want to show you today is the matrix plot. Matrix plot is a simple way to visualize the expression of genes. This is a heat map of average expression value per gene grouped by the cell clusters. Here, gene expression level was scaled from 0 to 1. 0 is the minimum level of expression, indicated by the white color, and 1 represents the maximum expression level, indicated by the dark blue color. Okay, that's it for today's video tutorial. I hope today's video tutorial could help you to produce beautiful images for your research paper publication. If you haven't subscribed my channel, please click the subscribe button after you watched my video. Thank you, and I'm looking forward to seeing you in my next video.